4.5 congruent triangles. So now we know that in congruent triangles, all three corresponding angles and all three corresponding sides must be congruent for them to be congruent. That's shown in this picture. Now, we learned some shortcuts saying like if we knew all three sides, then we knew all three angles are also congruent, right? Side, side, side congruence postulate. Well, if I can show all three sides, if the triangle's congruent, we can go back to that definition of congruent figures to show that all three angles are also congruent. So angle B is congruent to angle Y. Now, here is a really big idea. As you can see Einstein saying, it's called corresponding parts of congruent triangles are congruent. Okay, we abbreviate that for short as CPCTC. Okay, we're going to use that once we show that triangles are congruent to show other parts are congruent as well. Here's a first example. We know that AB is parallel to CD. So I'll mark my diagram with that. And BC is parallel to DA. So I'll use two arrows to show these lines are parallel. Prove that AB is congruent to CD. So I want to show that this segment is congruent to that one. And all I'm given is those parallel lines. Well, to do this, the first thing I'm going to do is start with my given. If I knew AB is parallel to CD, that's given. What do I know when I have parallel lines? I'm always looking for angles. So if I get my pen out here again, I'm ignoring these lines here for now. And I'm just looking at, here's my parallel lines and here's a transversal. This angle and this angle have to be congruent. So I'm going to find those angles, ABD. Angle ABD and angle CDB. And that is the alternate interior angles theorem. Okay, now I'm going to use my other given, that there, and I'm going to, with that other given, I'm saying this is my parallel line, this is my parallel line, here's my transversal. These alternate interior angles must be congruent. That's angle CBD. And that is also alternate interior angles theorem. Put some arrows in at this time. So that dot leads to that one, this dot leads to that one. And now that I know got one more thing. Let's say I don't want the AB yet. I need to show that BD is congruent to BD. Why is BD congruent to BD? Seems kind of obvious, but it is the reflexive property. So I can write on here, I have an angle, and one side. I have enough information to show that some triangles are congruent, but is it angle, angle, side, or is it angle, side, angle? So we have to look at where this side is located relevant to the two angles, and this side is between the two angles. So that would be angle, side, angle, which is already kind of given to us. So that's good news. Those triangles are congruent by angle, side, angle. And to get that statement, I'm using all three of these. I'm using all three of those pieces to come up with that idea. And then once I know those triangles are congruent, I know the corresponding parts of congruent triangles are congruent. Okay, so this is one thing that you might want to try on your You see the answer now, but you could go back to your regular notes and try to see if you can come up with the same flow proof. Now here we got to reorganize the following proof into a logical argument. So all these things are in the wrong order, and there's quite a few of them. Okay, so I can't quite fit it all into one page unless I can zoom out a little bit. Might help. There we go. All right, so hopefully you can still read it on your computer. I think you should be able to, but ray AC bisects angle BAB. So when we have an angle bisecting, right away I think, oh, that divides it into two congruent parts. So I start planning my proof right as I start reading the givens. So I'm thinking, okay, those angles are congruent because of bisecting. And AC also bisects this angle over here. So these angles must be congruent. And I want to show triangle BEA. BEA is congruent to DEA, these little triangles. Well, let's start with our givens. Way down here, move that down, move that up. And the reason for that is given. I already showed some angles from that idea of bisects. We have some angles congruent. And where we have angles. Definition of angle bisector. Alright, so once we have those congruent, my plan, I could show AE congruent to AE, but I need to use basically I'm going to show the big triangles congruent so that I know the corresponding parts are all congruent, and I can pick out some other information here to get these triangles congruent to each other. So I'm going to show the big triangles are congruent. So I need segment AC congruent to segment AC. That's the reflexive property. And now I have an angle, side, angle. So angle, side, angle. Oops, I messed up there. Triangle ABC. Triangle ABC, this big triangle, is going to be congruent to ABC. And once I have those congruent, I know my congruent parts. So let's see here. I'm going to say AD is congruent, this part of the big triangle is congruent to AB, its corresponding part of the other big triangle. Corresponding parts of congruent triangles are congruent. I wrote it all out there, but you could abbreviate CP, CTC. And now on this, I'm trying to show this triangle. Oop, I'm going to change colors here. Trying to show this triangle is congruent to this one. I have one angle. I just showed AB is congruent to AB. The last step I'm going to show is AE is congruent to itself. So I have a side angle side. Side angle side means these triangles are congruent. AE is congruent to itself by reflexive property. That's congruent by side angle side. There's your homework assignment. In 4.5, it's a lot of proofs. Give it your best shot. We will be doing a lot in class, so make sure you watch this video because I think it should help. And feel free to try to go back to the original notes and see if you can move things into place and see if it works. See you in class.